All right, so what we'll do is we'll go through the constant velocity, the Unit 6 worksheet 1. I'll go through and try and hit the key points. We'll go through each of the questions. I'll annotate on the graph to kind of try and show, what the answers are and kind of why the answer is what it is. So let me pull my annotate. Okay. So looking at number 1, so number 1 is referring to the first graph here. So it says, consider the position versus time graph below for cyclists A and B. So we're just looking at 2 different cyclists. So A says, do the cyclists start at the same point? How do you know? And then if not, which is ahead? So you can see here, do the cyclists start at the same point? They do not. Remember, the key thing for looking at the starting point is we're looking at the y-intercept or that y-axis. What we can see here is we pull or have this up, we can see cyclist A is starting basically at the 0 point or starting at the very bottom of the y-axis, which would be 0 meters. Whereas cyclist B actually got a little bit of a head start. So they're starting a couple meters in front of cyclist A. So they are starting at different points. And you can see here, cyclist B has a head start, or they're starting ahead of cyclist A. But again, the key thing when looking at starting points is the y-intercept, or where that line crosses the y-axis. Okay, then looking at B, here it says, at t equals 7 seconds, so at time equals 7 seconds, which cyclist is ahead, and then how do you know? So we're looking here, we can see we don't actually have a specific point for 7 seconds. We're starting at our 0 seconds and moving on, so 7 seconds, so you can just kind of do a rough estimate. I can kind of put it right, so we'll say, the blue line here would be 7 seconds. So the question then, says which cyclist is ahead. We can see cyclist A is ahead. And so they've traveled a further distance or further along the position or their distance. So you can see cyclist A is further along the position side or position axis. So what it tells us cyclist A is ahead or has traveled further than cyclist B. But at that point in time, you can see, they'd say here they're at, cyclist A is at 8 meters and cyclist B is at 7 meters. Yeah. Okay. So again to C, it says, which cyclist is traveling faster at 3 seconds and how do you know? Okay. So remember the key thing we're looking at speed in the line is the steeper the line, the faster that person is traveling. So we come back up here and we look at 3 seconds, which would be a little bit past half. So the green line would indicate, our 3 seconds. But again, the key thing we're looking at is the steepness of the line. Okay. So if we look at cyclist A, we can kind of give them a red line, and then cyclist B with blue. But since cyclist A, it has a steeper line, that indicates that cyclist A is traveling at a faster speed. Right? So they have a higher velocity than cyclist B. So cyclist B is traveling slower. I'm gonna leave those there for a moment. Okay. So again here, it says cyclist A, I know this because the line is steeper than the line for cyclist B. So a steeper slope means a greater constant speed. Okay, so then D asks, are their velocities equal at any time? Then how do you know? So one of the key things here is when we're looking at this, you can see, cyclists A and B, they have what we call a constant velocity. So if the slope of their line does not change, that means their speed does not change. So since A has a slope that is a straight line, they have a constant velocity, so their speed is not changing. Same thing for B, they have a straight line, so their speed is not changing. So since neither their velocity or their speed changes, since A has a steeper line, cyclist A is traveling at a higher velocity, and they never have the equal velocity. So they're always going to have their velocity, so you can see here, says, cyclists are traveling at different constant speeds the entire time. We know this because both lines are straight and cyclist A is steeper, representing or as a steeper line. So since they both have a constant or straight line throughout, cyclist A is traveling at a faster speed, which means they do not travel at the same speed at any point in time. Then the last question here is, what is happening at the intersection of lines A and B? So you can see, it says cyclist A is passing cyclist B. So what we're looking at here, we're looking at the point where these lines cross. So what we can see is, as cyclist B is traveling, what happens is cyclist A, that is the point at which cyclist A passes cyclist B. So at the 5-second mark, they're at the exact same position. Just before that, B is ahead. Just after that, A is ahead. So at this intersection, this is the point where cyclist A is passing cyclist B. So those are the questions related to graph 1. All right, so coming down now to graph 2. So we have a slightly different graph. All right, so question A asks, how does the motion of cyclist A in this graph compare to that of A in the previous graph from question 1? And so this is kind of a bit easier if you actually add a line in. So if we can I get this right on or close right on. Okay. So you can see here is the slope for cyclist A in graph 2. All right, so if we go up to graph 1 and compare, what we can see is, so we can get this just a tiny bit down. Close there. So you can see that they basically have the exact same velocity, the exact same slope. And so in this case, we can identify is that the motion appears to be the same. So since the slope is the same, they have the same velocity. Since they're both a positive slope, they're traveling in the same direction. So in this case, the motion just appears to be the same. And then B, the question asks, how does the motion of cyclist B in this graph compare to that of B in the previous graph from question 1? So if we look at B from question 2, and we'll do this as blue. Oh, let's try to get my line chosen. And then we compare this to B for graph 1. And try and get the line across the same point. So one thing that we can see from this is that we have, cyclist B from graph 1 has a positive slope, and cyclist B from graph 2 has a negative slope. So what this tells us that they're moving in the opposite direction. So in this case, cyclist B from the number 2 will be traveling from right to left, and then cyclist B from graph 1 will be traveling left to right. So since we have the opposite slopes, they're moving in the opposite direction. So here it says, cyclist B is moving in different directions in the graphs. Sorry, it's A and B, sorry. So in cyclist B in graph 1, they have a positive slope, and then in graph 2, they have a negative slope, so they're moving in opposite directions. Okay. And C asks, which cyclist has the greater velocity, then how do you know? And so remember, the key thing with velocity is looking at the steepness or how steep the slope is. So with cyclist A, you can see, the slope is steeper than cyclist B. So it tells us that cyclist A is traveling at a faster speed due to the fact that they have a steeper slope. One of the key things here, though, is you can be traveling in the opposite direction at the same speed. So if we kind of look at this and so say if our B slope was the exact opposite of A, and so say here we, slope A is a positive 5 meters per second, and in this case the blue line is a negative 5 meters per second. They're still traveling at the exact same velocity. They're just moving in the opposite direction. But according to this question, since we're comparing A to B, A is traveling at a higher rate of speed due to the fact that it has a steeper slope. That's kind of a key thing we're looking at velocities. We're looking at the slope of the line. Okay. So here it says, cyclist A has greater velocity because the line representing the motion of cyclist A is steeper than that of motion of cyclist B. Okay. Next question says, describe what is happening at the intersection of lines A and B. In this case, this is where cyclists A and B meet one another. Remember, in this case, they're traveling in the opposite direction. So we're looking at this point. All right, so cyclist B is traveling from the 6 meter mark to the 4 meter mark. All right, so they're going in the negative direction, so 6 to 4, where cyclist A is going from the 0 meter mark to the 10, so they're moving in the positive direction. So in this case, they meet one another, right, as they basically cross paths. So then the last question says, which cyclist has traveled further during the first 5 seconds, and how do you know? So in this case, you can see cyclist A has traveled further, and let me kind of plot this out real quick. All right, so for comparing cyclist A and cyclist B, so you can see cyclist A started at basically the 0 meter mark. And after 5 seconds, they were right about the 5 meter mark. So for cyclist A, they traveled from the 0 meter to 5 meters, so they've traveled 5 meters. Whereas cyclist B, they started about the 7 meter mark, and they traveled kind of the same points, the 5, so they've traveled about 2 meters. So you can see, kind of looking at it like this, cyclist A has traveled a further distance over those first 5 seconds. The other way you can think about this is that they travel for the same amount of time. The individual that has the higher speed will have traveled further. So since they both traveled for 5 seconds, since cyclist A has a higher velocity, that means that cyclist will have a higher distance that they have traveled over that time. So like it says, notice that cyclist A had a greater change in position compared to cyclist B. And that's kind of how I described there as a change in position. I show how they changed. Okay. So that's kind of going through Unit 6 Worksheet 1. It's kind of a quick review. Let me turn one thing off.